Okay, welcome back to part 2 of the notes. And a tip here, if you see, look in example 6, it's factor negative 12 minus x plus x squared. So it's not in the standard form of ax squared plus bx plus c. So just a tip, you should always place quadratics in standard form before factoring. Okay, so we're just going to rewrite this as x squared minus x minus 12, right? You keep the signs with the terms. And now we think about, okay, we need the product in this example to give us negative 12 and the sum to give us negative 1. So go ahead and pause the video and see if you can figure it out and then come back. Welcome back. So you realize that negative 4 and 3 gives us a product of 12 and a sum of negative 1. So our answer is x minus 4 times x plus 3. Okay, hopefully that made sense. All right, so because of time, we're going to skip factoring trinomials in 2 variables. I was looking and your book doesn't discuss it. So if we have time later on, which we probably won't, we'll come back to it. But we're going to move on to some other things in terms of with factoring trinomials that you'll need to know. Okay, this is just over here on the left is just something we've already just talked about. So again, just a conjecture, when you take a quadratic x squared plus bx plus c, and again, we're assuming this coefficient is a 1, then the factor, when you factor into linear terms, you want x plus, let's say, m times x plus n, where again, x, the product is your constant, m times n is your constant, and m plus n is your coefficient with the linear term. Okay, so again, we're going to just omit this for now, and omit this as well. Okay, so let's look at example 8. So one of the things you can do, and again, this is a section on factoring with a leading coefficient of 1, right? So this is a 4, so you might think, well, that's something other than a 1, which we're going to get to. But notice that there's a 4 common in each of those terms. If you looked at their prime factorization, there is a 4 common in each term. So we're going to, before we factor this quadratic, we're going to factor out a 4 from each term. Okay, and so when we do that, if you do some side work there, the first term, you're going to be left with m squared minus, if that 16 now becomes a 4m, right, because we factored out a 4 from it, and then minus, if you do the division, 81 divided by 4 is 21, okay? So it's something times something. However, over here in definition 5, a polynomial is factored completely if each factor in the final factorization is prime. And that means, going back to something I said earlier, just want to make this note here where I said it's an irreducible quadratic, it's also called a prime polynomial when you can't factor that any further, okay, like in this example. So I wanted to make a note there because your book will have prime polynomial. When you move to calculus, you'll learn about irreducible quadratics. All right, so going back here, so this isn't prime because we can factor that further. So we're going to factor, now we want to factor this. So if we take a look at this quadratic, then the product we want to give us is negative 21 and the sum is negative 4, right? And so we have, let's see, you can pause the video and think about it, but you should come up with negative 7 and 3 as the two factors that will multiply to give you negative 21 and the sum negative 4. So then our final answer, well, I'll say this. I'll write this as, so it's m minus 7 times, remember we're using m minus 7 times, my stylus is acting up, m plus 3. And so for our final answer, we can't forget that 4 we originally factored out, right? So it's 4 times m minus 7 times m plus 3. Okay. So hopefully that made sense. If not, the nice thing about this video is that you can go back and rewatch it. All right, so our last two examples for this section will be on this example 9. So factor negative m squared minus 3m plus 10. A note here, if the leading coefficient, so it's not 1, it's actually a negative 1. But if it's a negative 1, then what we do first is factor out the negative 1, and then we factor that trinomial. So I'm going to factor out a negative 1, and when you factor out a negative 1, that just means flip the signs of everything in your polynomial. So it's going to be m squared plus 3m minus 10. And so now again, we're going to factor this trinomial, a leading coefficient of 1, so we can use our same process where the product we want negative 10 and the sum we want to be 3. So again, thinking about this, well, 5 and negative 2 works, right? That's going to give our sum of 3. So that'll give us m plus 5 and then m minus 2. And so our final answer, we have to bring back that negative 1. And this step here, you can omit and just go ahead and write the final answer. I'm just doing this for your notes. You can really just go straight to this answer. So negative 1 times m plus 5 times m minus 2. Or you could just omit the 1 and just say negative m plus 5 times m minus 2. Okay. And then finally, let's look at this example here. So we're going to factor 4d to the 4th plus 28d cubed plus d squared. Okay. This is not a quadratic, right? It's not ax squared plus bx plus c, right? It's not in that form. However, let's find the GCF first. All right, of these terms. Okay, so 4d to the 4th, breaking it down, factoring it to its prime factorization, that's 2 times 2 times d times d times d times d. 28d cubed will be 7 times 4, but if I factor it into its prime factorization, is 7 times 2 times 2 times d times d times d. And then 32d squared is 2 times 2 times 2 to the 5th, so 2 times 2, that's 5 2's times d times d. Okay, and we have a 2 in each. Actually, we have 2 2's in each, and I think we have 2 d's in each, right? So that's the most we can factor out. And so our GCF then will be 4d squared. So if we factor out a 4d squared, then again, remember, you can just, if you factor it down to its prime factorization, you can just go ahead and look to see, well, what's remaining in each of these terms in terms of how you would write what's inside of the parentheses. So from the first term, we're going to be left with d squared plus 7d. Oh, I'm sorry, you all. I wanted to change this. It's not going to affect our GCF, but I want to change this to a minus 32d squared. It's going to make it work out better in its factoring process. If you went ahead of the notes, you see how it made it more complicated with that plus. So plus 7d and then minus 8. Okay. And so now we need to factor this. So we want the product to be negative 8 and the sum to be 7. Notice I stopped writing the table, but if you want to keep writing it in a table, you can. And I believe 8 and negative 1 will work. That's why I wanted to change that value. And so we have what? D. So let's go straight to the final answer. I'm going to skip that middle step right there because it's not really necessary once we get our product, our factors. So our final answer will be 4d squared times d plus 8 times d minus 1. And your last quiz question, number 3, is to check this answer. So multiply that all the way back through, and of course you should end up with the original expression here. Okay, we are done with the notes. I will see you in class.